All right, Eagle Batch, welcome. This is it, our very first lecture, and we're kicking things off with a super important chapter, real numbers. We're going to break it all down and make sure you understand it inside and out. Let's get started.
Now, before we do anything else, I want you to look at this. This is our mission. This is the goal. I want you to take your notebook right now and write this at the top of the first page. 100 out of 100. Seriously, every lecture, that's what we're aiming for. It's all about mastering the concepts, not just getting by.
So first things first, what are we even talking about? What are real numbers? It might sound a little fancy, but honestly, it's just the name for basically every number you've ever worked with. They're the true building blocks of math.
Think of it like this. You started learning with natural numbers, 1, 2, 3, just for counting. Then your teachers introduced you to 0, and suddenly you had whole numbers. After that came the negative numbers, which gave us the integers. Then you got all the fractions and decimals, which we call rational numbers. And finally, you met those weird ones like pi and the square root of 2 that go on forever without repeating. Those are the irrational numbers. You put all of those groups together, the whole big family, and that's it. Those are the real numbers.
Okay, now let's get into the two most important concepts in this whole chapter, HCF and LCM. Look, almost everyone learns the steps to calculate them. But the real toppers, the ones who score 100, are the ones who actually understand what they mean. So we're not just going to calculate, we're going to understand.
Let's break this down as simply as possible. HCF, the highest common factor, is the biggest possible number that can divide into both of your numbers without leaving a remainder. Now, LCM, the least common multiple, is the total opposite. It's the smallest number that both of your numbers can divide into perfectly. See the difference? One divides them, the other is divisible by them. Getting that straight is everything.
And getting that concept right isn't just for looking smart. It unlocks some amazing shortcuts that let you solve problems way, way faster. Let me show you exactly what I mean with a classic exam-style question.
So you see this on a test. They give you two big numbers, 306 and 657. They tell you the HCF is 9, and they want you to find the LCM. Now, you could sit there and do the whole prime factorization method for both numbers, but come on, there has to be a better way, right? Of course there is.
And here it is. I call this the golden formula. You have to remember this. It's a lifesaver. It's so simple. For any two numbers, their product is always equal to the product of their HCF and their LCM. Now, a huge warning here. This trick only works for two numbers. Don't even try to use it for three or more, okay?
Let's watch how easy this is. We just plug in the numbers. 306 times 657 equals 9 times the LCM. Now it's just basic algebra. To get the LCM by itself, we divide the product of the two numbers by the HCF, which is 9. You do a quick calculation, and bam, the answer is 22,338. See? So much faster than doing all that prime factorization work.
Okay, let's switch gears a bit. We're moving from a calculation problem to a pure logic problem. This next question isn't about how fast you can multiply. It's about how well you understand what numbers are actually made of. They're prime factors.
Think about this for a second. The question is, if you take the number 6 and raise it to any power n, can the final number ever end with a 0? Let's try a few. 6 to the power of 1 is 6. 6 squared is 36. 6 cubed is 216. They all seem to end in a 6. But what if n was a huge number, like a million? Is it possible?
There is one incredibly simple rule that solves this whole puzzle. For a number to end in a 0, it has to be a multiple of 10. And what are the prime factors of 10? It's 2 times 5. So that gives us our 0 rule. For any number in the world to end with the digit 0, its list of prime factors absolutely must have both a 2 and a 5. Not just one or the other, you need both.
So our game plan is super easy. We just need to look at the prime factors of our base number, which in this case is 6. And the prime factorization of 6, well, that's about as simple as it gets. It's just 2 times 3.
Okay, so let's check our ingredients against the 0 rule. We've got a 2. That's good. That's one part of the recipe. But where's the 5? Do you see a 5 anywhere in the prime factors of 6? Nope, it's completely missing.
And that leaves off to our final rock-solid conclusion. Since the prime factors of 6 are only 2 and 3, it doesn't matter how many times you multiply it by itself. N could be 1, or 100, or a billion. A factor of 5 is never going to magically appear out of nowhere.
And if you don't have a 5 to pair up with the 2, you can never make a 10, which means you can never end with the digit 0. It's simply impossible.
So, that was a pretty good workout. Let's quickly go over the most important things we learned today. These are the points you absolutely need to have in your notes for your exam.
All right, here are the 4 big ideas. 1. HCF is the biggest number that divides your numbers. 2. LCM is the smallest number that's divisible by your numbers. 3. Our amazing shortcut, the golden formula, HCF times LCM equals the product of the 2 numbers. And 4. The 0 rule. To get a 0 at the end of any number, its prime factors must contain both a 2 and a 5.
And that is a wrap on our first lecture. See, mastering these simple core rules can make all the difference when you're facing those more complicated problems. You all did a great job today. Keep up the amazing work, and I'll see you in the next one.